the Math Route by Sri Ranjani. Today's topic is all about matrices. A matrix is an array of numbers arranged in rows and columns, which is more similar to a seating arrangement. There are two elements. The horizontal element is called the row and the vertical component is called the column. Together, it makes a matrix. So this is one good example of a 3 by 3 matrix having 3 rows and 3 columns. The types of matrices include row matrix, column matrix, rectangular matrix, square matrix, identity matrix, also known as unit matrix, upper triangular matrix, lower triangular matrix. Also, we are going to see symmetric and skew symmetric. Let us see the types in detail. The order of a matrix is written as m cross n, where m denotes the number of rows and n denotes the number of columns. Rows first, followed by the number of columns next. This gives an order of any given matrix. We can construct the matrix using the order. The first type is the row matrix, which has exactly one row, that is one horizontal line of elements. The order of a matrix is written as m cross n. Here m is 1, 1 cross 3, whereas a column matrix has only one column. The order of matrix C is 3 cross 1, having 3 columns. The next type, square matrix with equal number of rows and columns. 2 by 2, 3 by 3, 4 by 4, etc. And hence m cross n is a better example of a square matrix. The next one is a null matrix or a zero matrix where all the elements remains 0. So any matrix taken, all the elements in the given matrix stays 0. The next type is the diagonal matrix, where it is a square matrix with zeros everywhere except on the main diagonal. The main diagonal is also known as the leading diagonal. As given in the example, it forms 3, 0, 0, 0, 7, 0 and 0, 0, 5. So the elements 3, 7, 5 forms the leading diagonal or the main diagonal. Identity matrix or unit matrix is more similar to a diagonal matrix where the leading diagonal elements remains 1 and having zeros elsewhere. A scalar matrix is a diagonal matrix where all the diagonal elements are the same scalar other than 1. So here it is 5 0 0 0 5 0 0 0 5. So if it is going to be replaced by 1, it becomes a unit matrix. Other than 1, it is a scalar matrix. The next type is the upper triangular matrix and the lower triangular matrix. A square matrix with all the elements below the main diagonal or the leading diagonal equal to 0 is called the upper triangular matrix. In simple words, if the numericals are present in the upper triangular format, then it is upper triangular matrix. Otherwise, it is a lower triangular matrix having numericals in the lower triangular format. The upper triangular values remain 0. Also, a rectangular matrix is one where m cross n, m rows and n columns, the number of rows and number of columns never remain the same, and m is not equal to n, it is a rectangular matrix. The next major difference is the symmetric and the skew symmetric matrix, where we introduce the concept of transpose. So the transpose of a matrix is interchanging its rows and columns. So a symmetric matrix is that a square matrix equal to its transpose. So A is equal to A transpose. Whereas the skew symmetric is where A transpose is equal to negative A matrix. So this is the major difference between a symmetric and skew symmetric matrix. So here to find the transpose, we interchange the rows and columns for a given matrix A, and to find the negative A matrix, we just multiply the given matrix with a negative sign and write the resulting negative matrix A. And this gives the difference between symmetric and skew symmetric. Thank you for watching. Stay tuned for more updates. Like, share and subscribe at the Math Route if you found the video useful and informative. Thank you.